Okay, so here we are back again. We're going to write out some KSP expressions for some insoluble compounds based largely on their formulas. We're going to be able to use ice tables eventually, but we shouldn't have to because all we're dealing with are the products and we know the stoichiometry for those products. So I'm going to give us 3 examples here. We're going to write the KSP expression for each. We're also going to look up the KSP value, the numeric value for K, in this case KSP. There's a table 17.1 in your textbook, and there's also a table back in the appendix that has a lot more complete list of compounds, table C6 back in the appendices, okay? So we're going to look at AlOH by 3. We're going to look at CaSO4. And we're also going to look at Ag2CO3. And we're going to write the KSP expressions for these without writing out an equation, because these are all pretty formulaic, if you'll pardon the pun, because we're basing them all on the chemical formulas. So if we write the KSP expression for aluminum hydroxide, AlOH by 3, the KSP, in terms of the setup, is the product, which are the ions, concentrations raised to the power of their coefficients in the balanced equation for dissolving them. And if you look back at the last video, if you need to, we wrote up the equation, and those coefficients that were subscripts in our compound became the exponents. So the KSP for AlOH by 3 will be concentration of Al3 plus times OH minus to the 3rd power. That's the KSP expression for aluminum hydroxide. If we look it up in the table, the KSP numeric value for aluminum hydroxide is 3.0 times 10 to the minus 34th, which is why we don't have a lot of ions at equilibrium, because the KSPs are so small for many of these substances. So this is the expression, this is the numeric value. Eventually we'll get to some problems where we start to calculate what's the concentration of each of these if we know what KSP is. We'll get to those, don't get ahead of me. Next up, we got calcium sulfate. So we have a different set of subscripts. We have to remember that SO4, 2 minus, is the formula for sulfate, so there's 1 sulfate ion. There's 1 calcium ion. So the KSP for this substance is concentration of Ca2 plus times SO4, 2 minus. Each to the 1st power, because there's 1 ion in the formula. And in the tables, KSP for calcium sulfate is 4.9 times 10 to the minus 5th. So we would suspect that we get more ions from calcium sulfate in solution than we would from aluminum hydroxide, but you still have to work those problems out eventually when the time comes, because there's more ions over here than there is over here, and that all comes into play. Okay, our last one is silver carbonate, Ag2CO3. KSP for this, we have 2 silvers, so it's Ag plus squared, CO3 2 minus. The 3 is part of the formula, so it's CO3 2 minus to the 1st power. And if we look that up in our table, that has a KSP value of 8.5 times 10 to the minus 12. So this lecture is analogous back to when we were doing KC, where we just set up the expressions. So setting up the expressions, what are they in terms of concentrations? Eventually we'll work some problems where we start subbing in some algebra for those and coming up with some real values. But the setup of the expressions comes straight out of the formulas. It's Al3 plus to the 1st power because there's 1 aluminum. OH minus to the 3rd power because there are 3 hydroxides. Over here, 1 calcium, 1st power, 1 sulfate, 1st power. 2 silvers, 2nd power, 1 carbonate, 1st power. Okay? Thanks for hanging in there, guys.